Okay, let us start our class. We will continue operating system from where we left off in the last class, rather, right? So we were continuing the class of introduction to operating system. So as part of the last class, we have discussed what is an operating system, the different definitions from the different perspectives, and then the features of the same and the different kind of services that it provides. We'll continue the same, and then probably we'll see the rest of the services that it's going to provide, like IO and other kind, and then we'll then probably discuss the types of OS. Yes. So, like storage device hierarchy, if we probably look at, from larger to smaller, larger is slower, of course, the smaller is the faster, right? So that's how registers basically available as part of your CPU are quite faster. Their latch circuitry is different from the other, so we cannot have basically the system memory, the cache, to be a larger one. Rather, the permanent devices that can be rather of a higher kind, a higher storage kind. Now, coming to IO structure, IO devices, we said, also going to be here implemented with the help of certain interfaces we have, rather, right? So these interfaces, we call it as device drivers also. So this will help the communication that happens between the CPU and these IO structures to be made possible. To start an IO operation, the device driver loads the appropriate registers within the device controller first. The device controller in turn examines the contents of these registers to determine what action to take, whether it is a read operation or write operation, to read a character from the keyboard or to write a character onto the console or the printer and all kind of thing, right? The controller starts the transfer of data from the device to its local buffer. Once the transfer of data is complete, the device controller informs the device driver via an interrupt that it has finished its operation. As I said, the entire operating system is interrupt driven. In order to initiate or to finish, once after finishing as well any device, it has to enable an interrupt. It has to send a signal to the CPU stating that I have finished, so that CPU can probably start another task or delegate another task to any other device, rather, right? The device driver then returns the control to the operating system, possibly returning the data or a pointer to the data if the operation was a read. For other operation, the device driver returns the status information. So basically here, while accessing the data from the memory, IO devices, they can rather directly interact with the memory and then access it. Basically, there are different kind of approaches with which probably the data available from the memory can be accessed by IO devices, right? We have programmed IO, and what do you have? Isolated IO, and then direct memory access. Direct memory access is one which is efficient, rather being implemented in IOPs as well, where the IO devices are allowed to access the memory directly. But then with the help of DMA controller, there's a DMA controller who will probably allow the buses, because always the buses are under the control of CPU, rather, right? So the CPU have to release the buses so that your IO device can relinquish those buses and then start communicating with the memory to access the respective data which rather it requires. So for that, again, there are signals like bus request, bus grant. These are probably you study as part of DMA, right? Direct memory access. We have that as part of our memory management in 5th unit, and that you probably study in computer organization also, right? The three different kind programmed IO and isolated IO. Then these all you're going to study in detail, rather, right? And then coming to IOP. IOP is after DMA, and IOP is basically making use of this DMA structure itself, rather, right? So when IO wants to access the memory, it first sends the bus request control signal, right? Then buses are going to be released by. There are two different kind of approaches which are being generally adopted by DMA. One is cycle stealing, another one is bus transfer, right? Every between every word access, even CPU can have access of one word. There's a simultaneous access of both CPU and IO in cycle stealing happens, but then in bus transfer, whatever, for the entire bus time, the IO devices are allowed to access the memory with the buses that have been released by the CPU. CPU does not touch the buses once it releases for a burst amount of time. So there are two different kind of approaches that are being adopted by DMA mechanism. We'll probably study that as part of our DMA when it comes, rather, right? Now, if you look at the modern computer, how does it work? The basic computer architecture is the one human architecture, of course, right? That you must be studying in the first year before it, as part of industry or computer organization. Initial stage, you study that. Fine. In one human architecture, there is only sending some kind of data process. After it gets processed, you get the output out of it, rather. But then, after stored program organization came into being, where the program instructions can be stored in this store program, and then from there that can be forwarded to that computer CPU, and then relentlessly, continuously you can rather send the instructions from the memory, and then the CPU will be busy executing all that instruction one after the other, and then producing the output. That could have happened after the stored program organization came into being. But then now, if you see the modern computers, in modern computer era, where you can probably see CPU is allowed to execute multiple tasks at the same time. How does it happen with the help of threads, rather, right? Every task is going to be considered as a separate thread, will have its own path of execution, so it can rather take all its resources as and when it required to get it processed to CPU, and then it will be executed. So all these threads are illusioned with a dedicated processor, right? This is called even virtual processing concept as well. Okay. If you look at the computer system architecture, there is a single general purpose computer, in initial days. Most systems have the special purpose processor as well. Then you got multi-processor system growing in use and importance, and also known as parallel systems, a tightly coupled system, called as, right. The advantages in multiprocessor, you find increased throughput. Throughput is increased. The number of instructions that it execute within unit amount of time is going to be more. Economy of scale, right? You can increase the size of the operations, right? Number of operations that you can probably scale it to a larger, and then you can thereby reduce the cost as well from economical point of view, and increase reliability. Basically, when you have certain errors and that have been identified, has to be recovered. So this is all being taken care as part of your multiprocessor, increased reliability that you can find. Here again, you find two types of multiprocessing. One is symmetric and another one is asymmetric kind. In symmetric, what happens? The multiple processors will work on the same instructions, right? Like what do you call, under this supervision of a single control unit, the multiple ALUs are going to execute the same instruction with different instances of the same. For example, you have an instruction called, let us say, CI equal to AI plus B. If you are working with arrays, right? For example, CI equal to AI plus B, where I is being varied between 1 to 7. So, for example, I have 7 ALUs, 7 processes. So all of these 7 are going to be dedicated with one operation out of the same instruction, right? So one is taking C1 equal to A1 plus B1, the other one is performing C1 C2 equal to A2 plus B2, like that. So if you look at single instruction, there is a single instruction but with multiple data streams, rather, right? So under the supervision of a single CPU, fine, the control unit. So this kind of processing you can probably perform, which you rather call it as SIMD kind of processors, right? Single instruction, multiple data stream processors, right? So wherein you can probably see the increased throughput, because rather if you go with a single processor for the same instruction, having 7 instances of the same instruction take how many units of time? 7 units of time. But then you have 7 processors working in parallel to execute the same instruction. and each one of them takes only 1 unit of time. So each one of them is executing one instance of the same. So how much amount of time if you probably together when all seven instructions are seven instances of the particular instruction is executed is going to be 1 unit, right? So this is how you call it as pipeline processing or parallel processing as well, wherein you can increase the throughput of the system, right? And another kind of approach is the asymmetric kind, right? In asymmetric kind, what happens? Each one of them given a separate instruction, right? They're not going to share the same instruction, right? So there's another kind. You have multi-core systems as well. This is how. Yeah. So now, after multi-processing, you got multi-core systems, right? uh, multi-core systems are advantages than compared to a multi-processing operating system, because multi-processing operating are quite expensive, of course, the other way around, right? Most CPU designs now includes multiple computing cores and a single chip. Such multiprocessor systems are termed as multi-core. Multi-core system can be more efficient than multiple chips with single core, because on-chip communication is faster than between-chip communication. One chip with multiple cores uses significantly less power than multiple single-core chips. An important issue for laptop as well as mobile devices is the power, of course, rather, right? Mm, multi-core systems are multi-processor systems. The other way around, you can say it gives you the same kind of feeling, right? Not all multi-processor systems are multi-core. A dual core, if you probably look at, where you find two different CPUs having their own respective cache, and then there is a common cache, right? So the common cache will have the instructions which are being rather taken from the main memory to be delegated across this CPU, and the load balancing of the instructions are going to be done across these two CPUs, and both the CPUs are going to execute the instructions parallelly in order to execute your task much faster at a much faster rate. Clustered system, like multi-processor system, but multiple system working together, right? Usually sharing storage via storage area network provides a high availability services which survive failures. Of course, sometimes asymmetric clustering has one machine hot standby mode. Symmetric clustering has multiple nodes running application monitoring each other. Some clusters are for high performance computing. Applications will be written to use parallelization. Some have distributed lock manager to avoid the conflicting operation. So in clustered system, you can see multiple clusters are going to work parallelly by sharing the storage area network, where probably you have the entire tasks that are required to be rather delegated across these particular computers, and the load balances will be done through this particular storage area network. Multi-program systems. Single user cannot keep CPU and IO devices busy all the time. Multi-programming, if you have multitask operating system, you can make the CPU busy rather, right? That's how the time sharing operating system came into being. Windows multitask operating system also came into being. Multi-programming organizes the jobs, code and data, so CPU always has to execute one or the other rather. A subset of total jobs in system is kept in memory. Like you look at in batch system, one job selected and run via the job scheduling. When it has to wait for IO, for example, OS switches to another. Because all the time a job may not require the CPU. It may probably need certain input from IO. Until it gets the input from the IO, the other process will be rather scheduled under the CPU, right? If you look at time sharing systems, of course, they work with the same kind of phenomena here. Logical extension of that system is the time sharing operating system, where CPU switches between the job so frequently that users can interact with each job while it is running, creating interactive environment. The best example for time sharing operating system is the Linux, right? It's also referred as multitasking the other way around. Sometimes we call it response time is less than 1 second, right? The unit amount of time that you got to basically this time sharing operating system will will be implemented using the round robin kind of scheduling algorithm, where you don't allow a single processor to be for a longer enough time until it gets its job finished with the help of CPU. Rather, a unit quanta probably employ, and then and you schedule the processes based on first come first serve to access the CPU for that particular quanta, and then once it finishes, it has to sit back into the queue to get its next before all other jobs which are entered into the queue have finished their turn rather, right? Where you can see several processes are ready to run at the same time. We need some kind of scheduling, that's not what the round robin as I said, and the swapping of these jobs are going to be done quite often rather, right? And virtual memory probably the concept which allows the execution of the process not completely because you are when executing probably as I said you don't need the entire program to be open because you are not going to execute the entire program at once. You will be allowed for a quanta. For a quanta, when you are allowed how many instructions you are going to execute, maybe some set of instructions. Only those instructions which you probably require to execute, you can bring in your memory. That's called swapping. Swapping the page, and then when it is not, when it is done with, then probably you can swap out and then bring in a new page. With the help of this virtual memory concept. With the help of page replacement algorithms, we have we'll probably discuss as part of our memory management in fifth unit, right? LRU, MRU, and FCFS kind. Memory layout for multi-program system will probably get, you have the multiple jobs entered into the ready queue, but once they are entered into the pool, they will be scheduled based on certain algorithms to access the respective resources. Basically, here the major resource is the CPU, of course, rather, right? The modes of operations you probably will quite, as you switch on the system, there are two modes parallelly running. One is user mode, another one is the kernel mode, right? So the mode bit 0 or 1 provides based on which the mode switching is going to be taken place rather, right? Because all devices as I said are going to be communicated with the help of certain signals, right? Obviously that signals are going to be 0 or 1 most of the times, right? Either you enable or you disable rather, right? It provides ability to distinguish when system is running the user mode or the kernel mode, right? With the help of this mode bit, 0 or 1, right? Some instruction designed as privilege only executable in kernel mode. Like for example, system calls, which are going to be rather executed in the kernel mode. System calls by user asking the OS to perform some function changes from user mode to the kernel mode. Return from a system call resets the mode to user mode, right? When you say written, it will be, so you can see the functioning of this particular system call when happens, how the switching between user and the kernel mode has been mentioned. User processes, you have the process executing. Then when you call a system call with the help of a trap, which is nothing but a software interrupt, you will enter into the kernel mode, right? The mode bit is 0, and once the system call is executed, then the mode bit is 1, and you will return back to the help of return statement, you will return back to the user mode, right? Basically, sometimes you set the timer as well. Otherwise, it may sometimes enter into the infinite loops. In order to avoid from entering into the infinite loop, you set the timer. Timer is a counter that is recommended by the physical clock rather, right? Timer is set to interrupt the computer after a certain amount of period. Operating system sets the counter, which is nothing but a privilege instruction basically. When counter reaches the value 0, an interrupt is generated. Fine, the signal is going to be created as said. The OS set up the value of the counter before scheduling a process to regain control or terminate program that exceeds the allotted time. Now coming to the process management, right? A process, as I said, is a program under execution, right? Program is a basically a passive entity. Process is an active entity, you can say, right? Process needs resources to accomplish its task. What resources that it requires? The major resource is, of course, the CPU. Then, in addition to that, it may require memory because all the time it has to fetch the instructions and data that are available in the memory. And sometimes it may need certain external data, for which, of course, I/O devices rather it requires, and certain information is available in the form of files in the hard disk. Also, sometimes it requires, and some initialization parameters to start with. Process termination requires reclaim of any reusable resources. A thread is a basic unit of a utilization within a process. basically thread is a subpart of process, you can say that, right? So is a basic unit of SQL. So the difference between the process and the thread is that the process will have its own address space, whereas thread will share the same address space, right? It's a subpart of process, you can say that, right? But feature-wise, from execution point of view, they are same. Thread is having its own path of execution. Process also will have its own execution path, right? And the threads can be scheduled. Process also can be scheduled. You can preempt the threads, like how the process can be preempted, rather, right? So you can set the priorities. You probably suspend. You can resume. You can do all such kind of operation. What probably you can do it on process on threads as well, right? The single threaded process instructions are executed sequentially one at a time until the completion. Processes has one program counter specifying location of next instruction to execute. Right? Program counter register, as I said, will have the instruction address which is to be next executed. The multi-threaded process has one program counter per thread. Typically, a system has many processes, some users, some operating systems running concurrently on one or more CPUs. Concurrency by multiplexing the CPUs among the threads. You can probably run the different threads on different CPUs as well, right? And then probably some kind of thread synchronization can take place after once they are going to be executed at different processes. Of course, this all comes under as part of your process management and thread management, right? The operating system is responsible for the following activities in connection with the process management: creating and deleting both user and system processes, suspending and resuming processes, providing mechanisms for process synchronization, providing mechanisms for process communication, inter-process communication, or intra-process communication, providing mechanisms for deadlock handling, right? Because when probably certain processes are allowed to be executed where one is dependent on the other, so hold and wait kind of situation encounters with that, you have a circular wait situation encounter, a mutual exclusion kind of situation encounter with, where probably what happens, these processes may enter into a deadlock kind of situation. So how to avoid such kind of deadlocks from happening and how you're going to detect and prevent them, we have certain algorithm with the help of which probably we take care of all that, right? As part of process management. Then coming to memory management, to execute a program, all of the instruction must be in the memory. All the program will be probably in the memory first. So the instructions are going to fetch one after the other from the memory. All of the data that is needed by the program also must be available in the memory, right? The memory management determines what is in memory and when uh, it is required, rather, right? Optimizing the CPU utilization and computer responses to users is part of your memory management. Memory management activities probably look at keeping track of which part of the memory are currently being used and by whom. Okay, deciding which process are part thereof and data to move into and out of the memory, allocating and deallocating the memory space whenever the memory space is required. So how does memory is going to be allocated? It has to find the free chunks available on the memory. So it manages with the help of a data structure the free chunks of all the available in the memory, so that using certain algorithms, right? Indexing we have, linked list we have, right? So using this kind of mechanism, it probably allocates memory as and when required to any of the tasks, and then it maintains at the same time if certain process have released the memory, that released memory has to be accounted into the free chunks, right? We'll see that all part of the memory management. Then coming to the storage management, OS provides uniform logical view of the information storage. Abstract physical properties logical storage unit is a file, of course. Files are stored in a number of different storage medium, like disk, flash memory, like your pen drive, tape, magnetic tape. Each medium is controlled by a device driver, right? Device driver is like an interface, basically, right? Which drives the devices, right? With the help of certain instructions, of course. Disk drive or tape drive. Varying properties include access speed, capacity, data transfer rate, access method, sequential, or random. Coming to file system management, files usually organized into directories, right? So file is the leaf. If you look at the directory is a tree structure basically, right? So you have root is the root directory you find at the home probably on your system. Then you will have the subdirectories of the same, like different users, and users will have his own subdirectories. And at the leaf part you find file. File is a atom in the directory structure, which cannot be further divided. Rather, it's a leaf kind of thing, rather, right? File usually organized into directories. Access control on most systems determine who can access what is going to be maintained here as part of the file system management. OS activities, includes part of file system management, are creating and deleting files and directories, primitives to manipulate the files and directories, mapping files onto secondary storage, backup files onto stable and non-volatile storage media. Coming to secondary storage management, which is permanent storage devices on non-volatile devices, as we call it as from storage point of view. Usually, this used to store the data that does not fit in the main memory or data that must be kept for a long period of time. Proper management is of central importance here. Entire speed of computer operation hinges on this subsystem and its algorithms. OS activity as part of this system management, if you probably look at free space management, storage allocation, disk scheduling algorithms, implementing, right? Some storage need not be fast. So for that, you have, like for example, tertiary storage includes optical storage, magnetic tape, still must be managed by OSR applications because they hold a lot of memory. It's a larger size one. The larger, as I said, is a smaller kind, smaller in access, smaller in accessing. Now coming to caching. Cache is a fast access memory. Basically, you find on the system, right? In order to increase the memory average access time, you use this caching, right? Every CPU will have its own cache. Important principle perform at many levels in a computer. We'll see how the data is going to be mapped as part of our memory management, right? You have mapping technique, associative mapping, and direct associative mapping, right? So information in use copied from the slower to faster storage temporarily. The what basically you store in cache is the data which is frequently being accessed from the main memory. Instead of going to the main memory, you can rather directly take from the cache, right? So it's a kind of log the other way around, right? It maintains a log. So the information which is frequently been accessed can be directly taken away from the cache instead of going to the main memory. It is something like you are bypassing the main memory to access certain data from the cache. Right? If it is information used directly from the cache, it is fast. It's around more than 50 to 100 times of your main memory, right? We'll see with the help of a table. That analysis is also there in the next slides. From faster to slower, from longer to smaller. Cache are smaller in size basically, right, than the storage being cached. Cache management, important design problems and size replacement policies as well you see as part of cache. Here you can see the performance of various levels of storage. Okay, if you look at registers, we'll have size in less than 1 KB, cache size in less than 16 KB, main memory less than 64 GB, solid state disk till up to 1 terabyte. You can have memory disk, you can have till up to 10 terabytes. But if you probably look at the access time you can see here 0.25 to zero point 0.5 nanoseconds from registers when you are trying to access, right? You must have seen register is one of the storage class in the C data structure, C storage classes, right? You have got 4 storage classes in C you have studied, right? Auto, static, external, register. So by default it is auto, but then in order to make it register, you have to basically mention explicitly that it's a register. The advantage of having register is the data is going to be stored directly in the processor register itself. So while performing the operation, it need not to access it from the memory, because when you're accessing the memory, it takes considerable amount of time, right? Considerable amount of time. Fine. So in order to avoid that time from accessing memory, you will probably go with this registers, right? So if the data could have been stored in the register itself, you can straight away go for the execution of the same. That's how you can probably see the execution of the pre instruction is going to be faster than compared to R2 or other kind. Fine. So here you can see if you are trying to access on main memory, it takes 80 to 250 nanoseconds, right? The bandwidth, if you probably look at, of registers, how many MB per second you can access from register is 20,000 MB to 1 lakh. Similarly, for cache, you have in main memory and I'll mention, right? The migration of data A from some disk to the register has to happen. You can see with different stages across, right? Multitasking environment must be careful to use most recent value, no matter where it is stored in the storage batch. If you have certain data in hard disk, that has to be transferred from hard disk to main first, then from main to cache it goes, then hardware register. This is how the hierarchy you find rather, right? Hardware register are quite closer to the CPU, right? All these instructions are going to be executed by the CPU at the end. After only they are brought into the hardware register. So if you have certain data, some A available in hard disk, that has to be brought here. So how much time does it take from hard disk to main memory to be, we have already seen here, right? And then from main memory to cache, we can see that much amount of time. From cache to hardware, you have seen, right? If it is already there in the register, it is faster. But then can you store all the instructions? No, not possible. So main memory is basically employed in order to store the instructions. So what we do is when we are trying to execute certain instruction, you don't bring only one instruction, rather you bring some set of instruction in the form of a page or a block or a frame, you call it as, right? It's going to be a 1K size sometimes, right? It's going to be 10K based on the manufacturer, hardware manufacturer, right? So the entire 1K page is going to be brought into the main memory, and the instruction that it consists of, so that 1K probably are going to be sent one after the other to the system for execution. Okay. Multiprocessor environment must provide the cache coherency. Basically, what happens? Some instructions is probably modified, right? Or some data is modified, then that has to be reflected across the cache as well, right? If it has reflected in the main memory but not in cache, and the CPU is trying to access it from the cache, then what happens? It may lead to some kind of discrepancy rather, right? So cache coherency is required to be maintained. We have write back system actually, right? Write through, write back. There are two different systems which are being employed in order to maintain this cache coherency. IO subsystems, you probably look at in IO you have different kind of peripherals rather, right? You have input, lot of input peripherals available. Now you can see how many peripherals are connected on my laptop, right? There are good number of peripherals. These are all considered to be IO devices rather, right? One purpose of an operating system is to hide peculiarities of hardware devices from the user. IO system responsible for memory management of IO, including buffering, storing data temporarily while it is being transferred. Basically, when you are trying to download certain YouTube, what happens? It is buffering at the same time it's getting played rather, right? So buffering is being done where as part of the registers that are associated with that particular respective peripheral. Fine. Caching, storing the parts of data in faster storage for performance. Pooling is the overlapping of output of one job with input of the other job. Basically, in printer you find this pooling spoolers rather, right? General device and driver interface, driver for specific hardware devices, considered to be the IO subsystems, right? Now coming to protection and security. Protection is a mechanism for controlling access of process to resources defined by the OS. Security, a defense of the system against internal and external attacks, right? As I said, one internal mechanism, thereby it probably a bit of external attacks also to happen from going to be prevented as part of Linux. This is the other class that access control matrix, right? So similar kind of mechanisms are being employed in operating system in order to prevent the different kind of internal and external attacks from happening to your system. Okay, denial of service, worms, viruses, identity theft and theft of service. These are all some of such kind of attacks. Systems generally first distinguish among users to determine who can do what. User identifies user identities such as user IDs, security IDs you provide. You have an authentication first of all when you enter into the operating system. You give the user ID. If you do not provide proper credentials like your password and all, it will prevent you from entering into the OS itself, rather, right? The user ID is associated with all the files. Sometimes you can probably have some kind of user ID to files as well, and you can have nowadays even in mobile OS files apps you got locking system, rather, right, with bio and normal pattern kind of thing, right? Group identifiers also can be used. Privilege escalation allows users to change to effective ID with more rights. And coming to virtualization, you can probably virtualize your operating system, right? You can have different instances of, guest OS, virtual OS that we have seen as part of our one of the case study of our lab programs, right? It allows the operating system to run application within other OSs. Vast and growing, like you can have Windows virtual machine on Linux and Linux intermediate. As you can have a host system of on host system of Linux, you can have a guest system as a virtual as a virtual one. The emulation used when the source CPU time is different from the target type. There is PowerPC to Intel x86. Generally, it is slowest method which is being emulation. Like you can have same type of working style of that particular thing that you can probably see with the help of this virtualization, right? Virtualization probably allow you to implement certain guest system, and also that can be natively compiled, right? Considers VMware running WinXP guest, each running application all on name WinXP host. You can run the applications on your host OS at the same time you can run on the guest OS. You can run both, virtual machine and your physical machine, and allow the task to be shared among this, and then let the different OSs running at the same time for you to increase the throughput. Virtual Machine Manager provides the virtualization services. Virtualization on laptops or desktops, you probably look at, it allows the users to install multiple operating systems to run applications written for operating system other than the native host. Apple laptop running, yes. Mac OS X host Windows as a guest, developing apps for multiple OSs without having multiple systems, testing application without having multiple systems, executing and managing complete environments within the data centers. You can see here the virtualization architecture, wherein you can probably see there's a single hardware, of course, right? The virtual machine manager is going to manage across the different kernels of the virtual machines with the different processes. Fine. If you probably look at the single system, the physical system, where you have a hardware and the kernel and single processes or processes, rather, right, given to the kernel. But then you can see these different processes which are employed with different path of execution via different kernels, right? But reaching the same hardware and getting it executed through the same hardware. If you look at the kernel data structure, it is implemented using the single linked list data structure, or doubly linked list, or circular linked list kind of data structure, right? You have the first, service, probably the init from where subsequent services are going to be linked, and then form a chain in order to provide the services of OS for the user. Sometimes binary search tree architecture also being used here, right? So as part of kernel data structure, you probably see the hash functions, hash maps, and then bitmaps. Coming to computing environments, you can find, yes, yeah, please. Standalone general purpose machines is one kind of computing environment. blood as most system connected with others. Portals provides web access to internal systems. Network computers, three kinds we call it as, are like web terminals. Mobile computer internet interconnect with wireless networks. Networking become ubiquitous. Even some systems use firewalls to protect home computers from internet attacks. So if you go with networking, probably since the computing is ubiquitous, you probably because any adverse user can come in to get the services to be used in cloud computing. That happens. So security is very much required. Of course, now you can see most of our computing is being done with the help of you know cloud as well, right? You need to have a huge architecture, computer architecture, in order to execute a very high computing algorithms, right? You can rather execute it on cloud, fine. And some of the computing are like smartphones, tablets, you have more OS features with GPS kind, and you have augmented reality. Metaverse have come up with the augmented reality, right? For which, of course, see most of the applications that you run on your mobile requires lot of computing time and power. But then, how is it being possible to get all that being done, provided the internet speed is good? Is because of the resources that it probably adopt is from the cloud, rather, right? And in operating systems, probably on mobile, if you probably look at Apple and Google Android, these are the leaders you find. In networking, you use 802.11 wireless architecture, IEEE architecture. Collection of separate, possibly heterogeneous systems network together. Network is the communication path. Using the different protocols. Basically, a protocol, basically what it does, it governs how the data to be transmitted among the two different entities, rather, right? You have TCP/IP and ISO/SI models, rather, right? But then many of the companies, they have their own kind of protocols. Like you have SNMP, VoIP for voice, right? POP or IMAP for mail. You have, right? SMTP for mail, of course, traditional mail server, simple mail transfer protocol. You have many such kind of, for each application, there are, for DNS application, you have different DNS protocol, right? In order to resolve the username. What is DNS? Basically to resolve the username, URL name. URL is basically given with a name, but then it is identified with the help of an IP address, right, on the internet. So how the mapping is going to be done with the help of this DNS, which is available with the help of DHCP protocol, right? Dynamic Host Configuration Protocol. So network operating system provides features to allow the sharing of data between the system across a network. Communication schemes allows systems to exchange messages, illusions of a single system, you feel that, right? And you can see the client server models in early days. Many systems now you have the servers. When you say it's a server, when it is having higher configuration, higher capabilities, right? And runs 24/7, you say it's a server. Any system can be made as a server, right? Your laptop, your desktop. Many systems now you can probably find it as a server. Compute server system provide an interface to client to request the services. What server does, it process the request put by the particular client, right? Most of the time you are trying to access certain data or perform certain operations, kind of thing, right? Yes, last bench. Fine. Peer-to-peer is another kind of network, right? Environment where you can see. I'm showing you the different generations. So right from your single desktop, before that you find a mainframe, and then how the transition took place. Uh, And then you can see now I'm probably reaching to cloud, right? Where probably we can see all our applications are running on cloud. Your drive, where is your drive? Is on cloud, right? You have huge amount of data available as part of your drive, right? I have my blogger, my website available. Entire data that you access it through the links published on my blogger is available in the drive. It's nothing but a cloud data, right? Another model of distributed system is a peer-to-peer kind, right? Does not distinguish client and the server. Anybody can be client, anybody can be server here, right? This system can request some service because that system is having some services, and this may be having some services that it needs, right? That's how exactly anybody can be a server and anybody can be a client. Nowadays, you find the same kind of scenario. Instead, all the nodes are considered peers. Each node may act as a client or server for both. Node must join P2P network, registered services with central lookup service on network, a broadcast request for services and respond to requests for service via the discovery protocol. The examples include Napster, Gotella, VoiceOver, or Skype in early days was found. Now we got WhatsApp calling also available. IMO, you have a lot of VoiceOver available, right? Now coming to the computing environment, like your cloud one, right? It delivers the computing, yes. Storage, even apps as a service across the network. All your apps that are running, they are running on your on cloud itself, right? Logical extension of virtualization because its user virtualization is the base for its functionality. Amazon EC2, one of such kind of cloud, right? Azure, right? You have a lot of such kind of cloud systems are available. They can probably use certain amount of space by paying certain amount, right, for your services. So Amazon EC2 has thousands of servers, millions of virtual machines, petabytes of storage available across the internet, pay based on usage. Now you can see they're providing different kind of services like software as a service, platform as a service, infrastructure as a service. You no more are required to develop your own softwares. You have, these kind of services available. You just have to, you know, tell your requirements and probably get it readily available by paying something rather, right? Even infrastructure, you don't have systems, but then you can pay and then get the infrastructure for your company, right? For software, you don't have to buy the license of the software. You can pay the amount to the respective company and then get the service software, licensed software to be used by your company employees, right? So to start up a new company, rather, right, for entrepreneurs, startup entrepreneurs, it is quite helpful. Rather, you need to buy everything right from the beginning, right from the building. Even DLF, you must have seen building, right, in Gachibowli. It is providing the infrastructure as a service, right? You have to pay the money and then get one block in it with all the facilities, right? And then probably you have to buy the software, the license software, by paying some amount for some amount of time, for example, for some tenure, for 1 year or 2 years, you can probably pay and then get the services of the same. Cloud computing environments composed of traditional OSs plus virtual machine managers plus cloud management tools. Internet connectivity is must for cloud services to access that, right? And of course, security, as I said, is more essential because any adverse user can access your credentials lying on cloud, right? Load balancer spread traffic across the multiple applications. When you have more applications, now to balance it among the users is one kind of phenomena that you have to adopt it. Then coming to the real-time systems, right? Basically, in air traffic management or missile launching, or your what do you call launching the satellites and all, you need real-time systems, right? Real-time embedded system, most prevalent form of computers, very considerable special purpose, limited purposes, OS, real-time OS, and its use is expanding now. Many others Now many private companies have started, satellite launching. You know, yeah, Amazon. Yes, yes. Amazon also has started, this satellite company in recent time. So real-time OS probably here is what required. Processing must be done within the constraint. Here it's all time bounded within that particular time that the particular processing has to be finished. If it delays with a nanosecond also, what happens? It is of no use rather, right? You have anti-missile system, for example. The anti-missile has to go and then strike exactly the time at which probably it has to strike that particular missile and then blast it off. Otherwise, what happens? It also acts like a missile instead. Yes or no? So, on the whole, I just wanted to conclude here. Open source operating systems are more popular and becoming more prevalent now. Linux is of that kind where you are allowed to add any kind of features to customize the same. We have Free Software Foundation. They have started with GNU Linux, and I am also one of the member of the same. You can probably customize it, right? Fine. Thank you for listening.